Good morning. Welcome to Room 2, to the workshop A Sustainable Future with Sustainable Plastics. We hope you enjoy. Today's first session is dedicated to the introduction about the general problem and to give a global vision about potential solutions. The first presentation will cover the following points: a brief introduction of my institution, ITIP Technology Center, and afterwards we will go through the age of plastics, the origin of these plastics regarding finite resources, what is the negative impact on the environment, the problem of complex materials, regulatory pressure, circular economy and circular bioeconomy as a new approach, an introduction to Mandala and Vicente projects, and then conclusions. Firstly, I will go through a very brief introduction of our entity, who is organizing this workshop in cooperation with collaborative partners working all together in the sustainability of plastics. ITIP Technology Center is a non-profit private entity which goal is to increase the competitiveness of the companies in the molds and plastic parts manufacturing industry, and as well as to spread knowledge and to transfer the know-how to face new technological challenges. This technological capacitation is directed to different sectors such as aeronautics, automotive, packaging, transport, energy, biomass design, ICTs, etc. Our team pursues the improvement of hybrid technologies and development and adaptation of novel materials to manufacturing processes. The R&D activity can be grouped into the following research fields: advanced materials, circular bioeconomy, digital transition, and flexible manufacturing, which is related to plastic transformation of thermoplastics and thermosets, and also mechatronics, robotics, and hybrid manufacturing, subtractive and additive. ITIP Universe counts as well with satellite spin-offs dedicated to the exploitation and commercialization of products and processes in different fields of the above-mentioned research fields. These are mainly technopackaging, MOSES, and Ensolver. The age of plastic. The invention of plastic has been a transcendent milestone in modern society, and this stage of humanity we are living in is known as the age of plastic due to its great social, economic, and environmental impact. Plastic is a material that combines certain characteristics that are difficult to find in other materials, as it is very light, it is moldable, it has high durability, it is, for example, very resistant, and also has a great visual appeal. So we can find it in our day-to-day in multitude products and sectors, from home, toys, cosmetics and cleaning products, cars, supermarkets, etc., etc. Thanks to plastic, we have much improved our quality of life. In the last 10 years, the plastic sector has grown uninterruptedly and is expected to continue to do so given that its current world demand increases between a 7 and an 8 each year. Its consumption has grown to reach 15.7 million tons in Europe in 2020 and increasing. Heading the ranking is the packaging sector, followed by construction, but also is very relevant in transport such as automotive, electronics, textile, appliances, etc. And we want to continue enjoying it. However, plastic has a weakness regarding its origin, that it comes from oil, which is a finite resource. If we see the uses to which a barrel of crude is intended, we see that in reality the proportion used for plastic is low, and still the consumption of plastics we have seen is very high. In this slide, we also show the Hubbard cycles, which try to calculate when the world zenith is reached regarding the depletion of oil reserves and even other fossil fuels, which means the existence of a production ceiling. The debate does not focus on whether there will be an oil peak, but on when it will occur. This depends on the possible discoveries of new reserves, the increase in the efficiency of current deposits thanks to enhancement in technologies, deeper extraction of the exploitation of new forms of unconventional oils, for example, such as fossil fuels, natural gas, methane, etc. Dependence on oil is also marked by geopolitical strategies, which we are experiencing in various areas of materials, such as critical raw materials, uranium, that are or their origin is from other countries and regions, such as, for example, Asia or Africa. Therefore, oil is a finite resource that should be reserved for high added value application, such as fine chemistry, and search for alternatives to other, such as plastic or for fuel transportation or heating, looking for alternative raw materials and renewable sustainable energies resources. In this sense, Europe has to become strong in technology, including any kind of bio-based sources and recycled and upcycled materials. In addition, the bad use that is being made with plastics at the end of life, when we dispose them, is generating a negative impact on the environment. Currently, the main alternatives are the landfill or incineration. The latest available data from 2018 shows that in Europe, some 29 million tons of post-consumer plastic is collected, from which 42% is burned in or as energy recovery, only 32.5% is recycled, and almost at 25% ends up in landfill. We have now even new polluting materials, known as such as plastic agglomerates and microplastics. Unfortunately, we have large spill or leakage into the environment that generate images like those shown in this slide, which affect fauna and flora. The problem is more serious than it seems, especially when plastics are fragmented, creating microplastics that pass up the trophic chain and are affecting humans' health. Advertising to raise society's awareness has focused a lot on the seas. The beaches are highly polluted, and what it seems to be sand has a high proportion of microplastics, and the exact amount in the ocean floor of these microplastics is still unknown. In addition, recent studies from 2017-2018 onwards are demonstrating that the impact on soil and land is even higher than in the oceans, and it is believed that there are 3 times more microplastics inland than in the oceans. This, in conjugation with pesticides, fertilizers, etc., is seriously affecting the soil and the way both of filtering water and erosion and capturing nutrients by plants is generating floods when there were no floods, generating toxic components for certain species of plants, etc., etc., which is the beginning of a promoter of the climate change. Since the 1950s, some 8.3 billion tons of plastic have been produced worldwide, and to date, only 9% of all has been recycled. So we have, and in particular, a special challenge for technological design innovation and recyclable technologies in multimaterial structures. They consist of multiple material types, combining, for example, different plastic types, thin metal foils, coatings, paper or cardboard, etc., that cannot currently be easily or mechanically separated. These are typically used in packaging, but also in other sectors such as construction. Unfortunately, increasing complexity to gain performance benefits also makes the final material much harder to recycle, and currently most multi-layered products usually ends up in landfilling or incineration plant. This poorly sustainable post-consumer scenario contradicts the concept of the circular economy. It must be highlighted that packaging has been given a lot of publicity as a hook to make society aware and engaged to the circular economy. Many efforts and investments in thermoplastics have already been made. However, such focus has not been placed on thermoset plastics, which are becoming a challenge for industry waste management, in particular those involving thermoset composite materials. The use of composite materials has gained interest in recent years due to their unique properties, such as high mechanical strength, good chemical resistance, and long durability, together with its great lightness and corrosion resistance, which make them very attractive for a large number of applications, such as aeronautics, automotive, construction, marine or naval, energy, sports, electronics, etc. Composite materials are formed by the combination of a polymer matrix, a resin, either a thermoset or a thermoplastic, and a reinforcing agent, carbon fiber, glass fiber, a natural fiber such as flax, for example. However, they still have many technical limitations, such as their end of life due to the inherent complexity of the difficulty in applying an eco-design generating plastic waste. In the case of thermoset composites, the problem increases because, unlike thermoplastics, these materials cannot be melted because they contain in their structure polymers with crosslinks that form irreversible chemical bonds which harden permanently once they are heated, hindering their recycling. Nowadays, composite materials are stored in landfill, including, for example, aircraft, wind blades, and railway cemeteries, and very often dedicated to energy recovery, are burned or thermically recycled. Due to their inherent heterogeneous nature of the matrix and the reinforcement, at present, the resin part is incinerated and the reinforcement, usually the glass or the carbon fiber, is recovered and reused as reinforcement for other applications, although the fiber fabric is many times damaged and cannot be used for the same purpose. Anyhow, there is now research regarding chemical and biological innovative solutions to resolve the end-of-life issues of thermoset composites based on the development of new sustainable technologies focused on the controlled separation and recovery of components, thinking even in upcycling applications without losing the value of all the materials. In addition to all the technical pressure, industrial pressure, market pressure, it is important to highlight the regulatory pressure too. Europe is pioneering the world in policies of circularity, recycling, reuse, and reduction of finite resources in favor of renewables, as we have no reserves. We are strong in technologies and in learning how to manage available resources very well to achieve neutral carbon cycles. The European Commission has presented the new policies and regulations in this topic collected under the European Green Deal, that is a roadmap to make the European economy sustainable by transforming climate and environmental challenges into opportunities in all areas of action and making the transition fair and inclusive for all. This is the frame of the novel European strategy for plastics in a circular economy. This was launched in 2018 and established by the Directive 2019/904 on the reduction of the impact of certain plastic productions on the environment, with measures like prohibiting some single-use plastic products that would be promoted the use of readily available and more sustainable alternatives, as well as of innovative solutions toward more sustainable business models, reuse alternatives, and substitution of materials. Brands and manufacturers need to explore all options to find the most responsible choice for the application pursued. Due to this framework that we have now, a new economic concept is arising. The first one is the circular economy, in which the new plastic economy is framed. A circular economy aims to keep products, components, and materials at their highest utility and value at all times, emphasizing the benefits of recycling residual waste materials. Talking about plastics, there are three main ambitions: create an effective after-use plastic economy, which involves recycling, reuse, and control biodegradation or compostability; reduce the leakage of plastic into the natural systems; and finally, decouple plastics from fossil feedstocks. Within this third option, we can introduce the bioeconomy concept too, by incorporating or integrating these renewable source feedstocks as origin for the materials into the value chains. The combination of these two approaches gives rise to the circular bioeconomy strategy, whose scope have different definitions according to experts. But personally, I like to think that the combination of both provides a synergistic effect. Finally, I would like to briefly introduce the following two projects, Mandala and Vicente, which ITIP coordinates under the Bio-Based Industries Initiative. These projects are developing novel solutions to boost the circular bioeconomy and try to solve the current end-of-life problems that are arising with these kind of complex materials. On the one hand, the purpose of Mandala is to find innovative solutions based on eco-design principles by developing new adhesives through the lamination of multi-layer, multi-material plastic structures with a dual functionality. First, easy to split, and at the same time increasing barrier properties. This is achieved by incorporating thermoreversible bonds based on a Diels-Adler reaction and radiation-absorbing particles in the adhesive, allowing the separation of the layers and reaching end-user specifications. Therefore, the end-of-life phase for multi-layer packaging becomes significantly more sustainable. Dr. Gary James Ellis will give you more details in the next session. On the other hand, the main ambition of Vicente project is to demonstrate the potential of a family of enzymes, lignisases, for the degradation of thermoset composite based on epoxy, polyesters, and vinyl esters resins in order to provide a solution for the end of life to avoid landfill or incineration. These three target resins are the most used in aeronautical, railway, energy, and construction sectors. Vicente project uses a strategy called directed evolution to design customized enzymes. This is based on protein engineering and allows to customize enzymes by mimicking the processes of natural evolution in the laboratory. The designed enzymes are able to selectively attack chemical structures and bonds from the chemical resins used, and the products obtained after the enzymatic biodegradation process are typically the different chemical building blocks and the reinforcing fibers, which are afterwards characterized to apply valorization strategies. Dr. Miguel Alcalde will give you more details in the third session. As general conclusions of this aperture session, I would like to highlight that there are many efforts put in different recycling technologies related to plastics and complex structures. And as society, we will need the combination and complementarity of all of them to achieve European goals of climate neutrality by 2050. And we would like to regard the potential already shown by chemical and biocatalytical routes. Thank you so much, and if you have any question, I will be glad to answer during the questions and answer session. Thanks.